Okay, let's get this mole journey going here. So because there's so much information to talk about, I'm going to do my best to try and keep it brief. So I don't even know really where to start. It's kind of a lot to talk about. So I'm going to go ahead and start with the main project that we're doing. So what we did is we just did this part, question number 3, where we did a conversion of mass into our percent into mass for each of these substances. So what we're now going to need to do is we're going to need to compare our polluted air sample with the air sample that we took that was clean. But you see here, what our measurements are in volume and in density, grams per liter of air. So that means in order to compare our polluted air sample with this original air sample, we also need to be in the same units of measurements. If you remember, we were talking about that. At this point, we know the mass of different gases, and we can calculate that. So we talked about up here where we're doing some mass calculations where we're using density and things like that. Here in question 2, we also did a mass calculation where we used density. But currently, what we don't have for our polluted air sample is units of measurement that will allow us to match it with these units of measurement here. So this is where our mole idea is going to come in, the whole unit conversion process. So let's start right here after question 3. So what I've done here is I've summarized again the notes that I went over last class. So let me just read through these. It seems like as good a place to start as any is to review exactly what a mole is and who this Avogadro is. So now that we know the mass of each gas within the sample, so we have the mass right here in question 3 of each of these gases within our unpolluted air sample, we can use the chemistry concept called Avogadro's law. So Avogadro was an Italian scientist and lawyer who was the first to calculate the total number of gas particles present in 22.4 liters. He found that regardless of the gas, the total number of particles within that 22.4 liters of volume remained identical. He calculated that number to be 6.022 times 10 to the 23 gas particles under the conditions known as standard temperature and pressure of a gas. So this is real important if you remember back to last semester when we talk about any type of gas experiments. So it must be done under standard temperature and pressure of a gas. And that standard temperature is 0 degrees Celsius and the standard pressure is 1 atmosphere. So this number has a special name, Avogadro's number. So this 6.02 times 10 to the 23 gas particles is called Avogadro's number in honor of the scientist who discovered it. So the mole is the most important concept in chemistry. This is like I was talking about last class. So this number was so large but useful in counting atoms and molecules that scientists needed to find a way to represent this quantity in a more manageable way. So from this necessity, the unit mole was created. So the total number of gas particles in 22.4 liters of volume is 1 mole of gas. So again, Avogadro's number, or 6.022 times 10 to the 23 individual gas particles. So this was used as the standard, equaling 1 mole. So they picked this to use as the standard measurement in all of chemistry. So it doesn't matter what we're measuring, could be gas or it could be a solid like salt. All measurements are taken in the unit mole. So from this discovery, we now have Avogadro's law, which states that 1 mole of any gas occupies 22.4 liters of volume, or 1 mole of gas equals 22.4 liters of gas at standard temperature and pressure. So this only exists at the standard temperature and pressure of the gas there. So you got to put that in. So I know this is a lot to take in, but we must add one more concept to this in order to solve this group of problems. So as you can see from question number 2, our gas particles are currently calculated in the unit grams. Unfortunately, our new concept of the mole does not say anything about grams. So our concept up here of a mole, 1 mole of gas equals 22.4 liters. They're not talking about grams yet, but if you guys remember back to last class, you know where this is going. So let me see, where was it? It only compares total particles to the created unit mole. So fortunately, chemists have long known what the mass of a single atom of an element is. This means that they were able to calculate the mass of 6.02 times 10 to the 23 atoms or molecules of any substance. So they were able to take the mass and find, they were able to take their known mass of a single atom of an element and find out what the mass of this number of atoms of that element would be. So this is where the news gets even better. The mass of 1 mole, or 6.022 times 10 to the 23 atoms, or Avogadro's number, is equal to the masses found on the periodic table. So that means that in order to determine the relationship between 1 mole of any element and its mass, all we have to do is find the element itself. So we just look to the periodic table, or the elements that make up a substance on the periodic table. This fact gives us another mole relationship. So this was our second definition of the mole. So here we can say that 1 mole, or 6.022 times 10 to the 23 units of any substance, is equal to the mass of that substance, the molar mass of that substance, where the molar mass comes straight off of the periodic table. So below, I'm providing a sample problem using this information. As you'll see, the process of solving the problem is exactly the same as everything that you've been doing successfully to this point. All that's changed are the new units to measure that we're placing in the equation. So these are my steps here that I was telling you last class that I created for unit conversion questions. And like I was telling you before, what makes these so difficult is these units could be anything. There are an almost infinite number of ways that are units that you could be converting from and into. So it becomes difficult. But over time, as I was doing these questions, I started to realize that there were a set of core steps that I could go through that would allow me to build my equations regardless of what units were being put into this. So that's what this particular instruction is going to be over. So this is where we're coming here. So if we go down and we skip through the steps, we're going to go down to question number 4. Let's just take a look at where we're headed here. So phew, that was a lot of information. The good news is that this is the hardest material to learn for beginning chemistry students. If we can master it now, the rest of the class will seem easy by comparison. So let's take a look at what the question you'll ultimately be tasked with as was solving on this is. So your task is to convert the masses of the gases in the air. So we come up here, these masses from question 3. So we're going to convert these masses, these mass values, into liters. So using the conversion process. So take a look at this, convert the mass of nitrogen gas from problem 3A to liters of gas. So that's our conversion that we're going to be doing. So let me put this away for the moment then. So let's go over to these steps. So here are the actual steps. So before I start to do some practice questions, I just want to read through the steps here. So then we'll go over and we'll start to apply these steps. So remember what I was telling you at the beginning of last class. I was telling you about how one of the great things, at least from a chemist perspective, that the show Breaking Bad did is it really gave people an understanding that they can relate to of what a chemist is. Remember I told you that a chemist really is just a cook. That chemist is a chef. They spend their entire day cooking different compounds up, just like a chef spends his day cooking different dishes up. So in order to correctly cook whatever it is they're trying to cook, the chef needs to follow a recipe. So the chef needs to know exactly what ingredients go into the recipe. And not just that, but need to know exactly how much of each ingredient to put in. Because we all know that all ingredients don't go in equal amounts. So if you're baking a cake, you're not putting 1 cup of everything into your substances, or even better for us, because in science we measure by mass. They're not putting 1 pound of sugar in and 1 pound of salt and 1 pound of flour and 1 pound of food coloring. Everything doesn't go in equal quantities. So for a chemist, it's exactly the same thing. The chemist also needs their recipe, but on that recipe, it doesn't just tell the chemist what the ingredients are that are going to be needed for that particular substance that they're going to be cooking up. That recipe also tells the chemist how much of each of the ingredient is needed. So just like with cooking, not all of the ingredients are used in equal amounts. So think back to the example I just did about a baker baking a cake. So for that baker in this country, they use mostly the measurement technique of cup. So they'll measure liquids out in cups and things like that. This is one of the only countries that does that. If you go over to England, and anyone that's ever watched the Great British Baking Show on Netflix knows, everything over there is measured out by mass. So they're not measuring out cups of anything. They put up all of their ingredients on a scale or a balance, and they measure stuff out in grams. So that's much more like what a chemist does. So a chemist does exactly the same thing. So a chemist measures out the quantity of each ingredient in mass. So remember what we just talked about when it comes to the definition of a mole. So a mole is a counting number. We count by moles, 1 mole. We need 2 moles of this, 3 moles of this. But we don't actually have any measuring equipment that we can put a chemical onto and it will read out 1.2 moles of a substance. Instead, what that chemist has to do is they have to take the number of moles they want and turn it into a mass number so that they can then go over to the balance and get that mass. So that's what these steps are here to help you with. So let's take a look at an example question here. So we've got our cook, our chemist cook, that is going to be cooking up a substance. So a certain materials chemist recently received an order from a large household cleaning product manufacturer for 2,000.0 grams of ammonia. And this is the chemical substance, ammonia. So that's the chemical formula for ammonia. So ammonia is produced on a large scale through the use of a process known as the Haber process. So the following balanced chemical equation shows the actual chemical reaction. So what you see here is a chemist's recipe. This is the recipe that a chemist follows. So whereas a chef might have a bullet pointed list of ingredients and then instructions that say, first add 2 pinches of salt to a hot pan or something like that. A chemist, on the other hand, is reading their recipe like this. So when they read their recipe, this is what they see. So what they see is 1 mole of nitrogen. So remember, in math, you can always put ones everywhere, and it doesn't change the actual value. So here, you could put a 1 right in front of this nitrogen, this N2 molecule, but it's just never shown by convention. So what the chemist is seeing here is 1 mole of nitrogen plus 2 moles of hydrogen will produce 2 moles of ammonia. So that's exactly the recipe that this chemist is looking at, and it's the way that chemist is going to read that recipe. But if we go back to the order here, this particular person, the person who's placed the order, has not placed the order for 2 moles of ammonia. They've placed the order in a gram amount. So they told this chemist that they would like him to produce 2,000 grams of ammonia. So if we look at our recipe here doesn't say anything about grams. And this is always a chemist's life. They never run into a situation where they're not needing to convert back and forth between grams and moles. So this chemist needs to know, this chemist knows that they need to produce 2,000 grams of ammonia. But their recipe is not measured in grams. Their recipe is written out using the quantity mole. So they have to get to the point where they square this circle. So they have to equate the 2 measurements. So that's what it says down here. In order to determine how much of the reactant he needs to produce 2,000 grams of ammonia, he must first know how many moles of ammonia will be needed to produce. So my recipe is measured in moles. The quantity that I'm tasked to produce is measured in grams. I need to get this measurement into this measurement. So I need my measurement here, my gram measurement, to match what my actual recipe is measured in. So what needs to happen here is this. This is the question. How many moles of NH3 are there in 2,000 grams of NH? So I need 2,000 grams of NH3. I need 2,000 grams of ammonia. My recipe tells me that this amount of nitrogen and hydrogen will produce 2 moles of ammonia. How many moles then is this? So how many moles of ammonia am I actually going to have to produce? So this is where now the unit conversions come into play. So like I said, these questions can take an almost infinite variety of wording or units or anything like that. So it's what makes them so difficult. But through my own failure and much of my own failure, I've gotten to the point where I put together a set of steps that allow you, just like the math steps we've been using, to take one of these questions, and regardless of what it's asking you to do, which units it's asking you to convert, it will allow you to start to build an equation so that you don't have to try and memorize 1,000 different conversions, 1,000 different ways to convert one unit into another unit. Instead, we simply use the same framework every time we do any type of conversion question. So how do we go about solving this type of question? So the very first thing that you need to know is you have to recognize what kind of question is being asked of you. You have to recognize that this particular question is different than all of our other questions. You have to recognize that there's no set equation that is used every time for this type of question. So first we must recognize what the question's asking for. So in this question, we see the key phrase, how many? This tells us that we will be converting one unit of measurement to another. So when we look at any type of conversion question, really there's going to be two things that you see in this question. And that's going to tip it off. That's going to tell you, oh, this is not a regular math question. I'm actually going to have to convert some units here. So one of the two things that you can see is this phrase, the phrase how many. A second phrase that you could see, or a second word that you could see, is this. The question could simply ask you to convert, say, meters into millimeters. If you ever see a question that either says how many or convert, in my class, we're dealing with the unit conversion process. What that means is we're going to use what I'm calling a fraction bar method. So if you see the phrase how many or convert, you immediately need to think, oh, fraction bars. So as soon as we think converting, we think of the fraction bars and the steps of solving those problems. So let's go about now building the steps, building our equation. So that's the point of these steps. The point of these steps is to build an equation for you. Since every question is different, I need to go ahead and build an equation so that I'm able to solve the question in the end. So the very first thing that you do when you recognize that you have a conversion question is to rephrase the question by putting it in the following form. So just like before, when we were talking about the math steps, the first 5 math steps were all about listing stuff out and labeling it. So this is essentially what I'm doing here. I need to get rid of this question. I don't want to read this question and try and pick out what it's asking me and then risk getting confused. So I want to pull my information out of the question. So in this case, I have to do it slightly differently. So what I'm going to do is write it in this very form. So I'm going to take whatever the question is, and I'm going to rephrase it using these same 3 parentheses. So the very first thing that I'm going to write in the first set of parentheses, I'm going to write down convert. And then what I'm going to do is I'm going to put in whatever amount I've been given. So what amount have I been given? That'll go here. And then I'm going to put in the unknown at the end. So convert whatever I'm given, and then I need to know what it wants me to convert it into. So that's what we have here. So if we look at this question, I see the phrase how many, so I'm going to think fraction bars, and then I'm going to say convert. So that means I'm going to need to rewrite this. So the very first thing I'm going to do is write down the word convert. Then in the next set of parentheses, I'm going to write down whatever I've been given. So here I go back into the question. And I've been given this 2,000 grams of NH3. It's the only number I'm given in here. So that's the amount that I've been given. So there we go. I'm going to put that in. And then lastly, I need to know what I do want. So I don't want my unit to be measured in grams, but what do I want my unit to be measured in? So this is where I go back to the question and I find my convert, or I find my how many. So in this case, what it wants, the question is asking, is moles. So that's what I'm going to put at the end. So I don't want to know how many grams of NH3 I have. I need this measurement to be in moles of NH3. And again, remember, I need to be in moles of NH3 because my recipe is being measured in moles. These are mole numbers. So each of these numbers that you see here are an amount of moles. So we have 2 moles of hydrogen, and so on. Okay, so that's always step one. It's always to rewrite your conversion question using this little phrasing. So the reason that I want you to do this is I'm going to use this to start to build my equation. So I'm going to cross each of these parts out one at a time. And each of these parts is going to tell me to write something down. So we're going to go on to step 2 next. So when I see this word convert, it means fraction bars. So we can now break down the note that we just wrote and use each part to set up our equation. So when we see the word convert, what that tells us to do is put down fraction bars. So the first thing I'm going to do is I'm going to cross out the word convert. So that's going to tell me to write this little setup down. I'm going to write a fraction bar times fraction bar and then an equal sign. That's what the word convert will tell me. And again, this is what really helped me when I started writing this note down. Because every time I had a conversion question, I would write this note down. I would remember what each of these little parts was telling me to do. I'd see the word convert and I'd say, oh, what that means is I'm going to need to put some fraction bars down. So that's what we're doing here. So we're going to cross that out now so we can come on to step 3. So notice here that I've crossed out the convert part. That's because I'm done with it. That word convert got me to write these fraction bars down. So next we use the given. So in this case, 2,000 grams of NH3 to fill in the numerator of the first fraction bar. So now I've got my fraction bars written down. I've crossed out my first part. So now I go and I'm going to use my next part of the note to help me build my equation. So what I always do with my given amount is I drop it into the numerator of the first fraction bar. So it always drops in right up here to the numerator of the first fraction bar. And again, the fact that I wrote it down here and I write it down every time allows me to always remember that. It just becomes habit. I write it down and boom, I drop it straight down into that spot. So now I can cross that out. We can move on to step number 4. So notice that now I've crossed that part of the note out. Look what's happened with the equation now. All of a sudden I'm starting to build an equation without having to think about anything. So without having to try to guess what goes where. So we're going to go on to step 4. I still have one part of the note left. I got this back part of the note. So what do I do with that? I always do the same thing with it. So when we use the last part of the note? So here what I do is I fill the end of the equation in it. So I go into the end after the equal sign, and I take that last part of the note and I drop it into the back of the equal sign there. So now look what I have. So because I wrote this note down, I have a beginning of an equation and I have an end of an equation. I'm really starting to build out this equation without me trying to guess at what goes where. So we can now go on to step 5. So we now place a 1 in the denominator of the first fraction bar to prevent us from placing something else there that doesn't belong in the spot. So really nothing for our purposes in this class goes in this spot. But what does your mind do when it sees a blank spot in a math equation? What it does is it wants to put something in there. It thinks something goes in there and it wants to put something in there. So what I found myself doing is I would just stick numbers in here. This blank would bug me. So I was convinced something must go in there and that I was just missing it. So I would just start putting numbers in there. And those numbers don't belong there. Nothing belongs there. So what I would do then is I would get stuff wrong. So what I just decided to do is I'm just going to put a 1 there every time just to keep myself from putting anything else there. So now look what's happened. Our first fraction bar is already filled in. We have an ending to our equation. We know what units of measurement we want to end in. I just have 2 blanks left in this equation. And all of a sudden now I've got an equation. So let's see how we fill in these last 2 parts. So step 6. So this leaves us with 2 blank spaces within the equation. So before we put in any numbers here, remember we first need to fill in the units of measurement. So you've been hearing me all year talk about how important units of measurement are, that you never ever write a number down that's not attached to units of measurement. You're now going to see why this is so important. This particular process is impossible to do if you don't have units of measurement on your numbers. If you just wrote 2,000 down here, you'd be lost. You'd already be done. You wouldn't be able to finish this question. Every single number you ever write down in math and science is a measurement of some kind. It has to have a unit of measurement on it. You need to know what that particular number is measuring. So What I do with step 6 is, and this is why I move stuff to the back. It's why I filled in this back part, because whatever I put back here always flips to the top of the second fraction bar. So whatever I put after the equal sign here, remember, I know what goes after the equal sign because whatever I put in the last part of my note is what drops into that last part of the equation behind the equal sign. So I hope you can start to see why I do this step by step, because every step that you do allows you to do the next step. It allows you to take what you've put in there and do something else with it. So because I filled in this back part of the equation, I'm able to flip that into this spot. So the unit of measurement that goes in this spot right here is whatever I've put behind the equal sign. So there we go. Now I've only got one gap left in this equation. That's it. So we go on to step 7. Where does that gap come from? So in the last blank space, we place the unit of measurement that we're looking to get rid of. This is the same unit of measurement that's in the numerator of the previous fraction bar. So in this particular example, it's grams of ammonia. Again, this is, now you can see why you would have been done on this question if you hadn't put this unit of measurement down. If you just had 2000 here, you wouldn't know what to put down here. So the entire purpose of this process, the entire purpose of the dimensional analysis process is to cancel units out. So remember, how do we cancel anything in math? We do the opposite of what it wants us to do. So here it's asking us to take this unit and multiply it by this. So in order to cancel it out, I need to divide it. So whatever unit you put here at the top of the first fraction bar is the unit that also gets repeated in the denominator of the second fraction bar. So whatever we put here, we always flip down here. So again, if you don't put anything here, you'll have no idea what to put down here. Now look what we've got. We've got an entire equation filled in. So all simply by following these steps, one step at a time. The only thing I now need to know is what numbers go by these units. So again, if you didn't have these units here, you wouldn't have any clue where to find the numbers from. So let's see where we get the numbers from for these. So now we have units in every spot. All we need to do is remember what numbers go next to them. So we always place a 1 next to the unit mole. So wherever you see the mole, so in this question, you see mole at the top. In some questions, you'll see mole at the bottom. It doesn't matter. Wherever your unit 1 is, wherever your mole unit is, we place the number 1 next to it. So this comes straight from the definition of a mole. So remember here, the definition of the mole we're using is the definition that says 1 mole of a substance is equal to its mass. So remember, grams is a mass measurement. So what this fraction bar is the mathematical relationship. It's the definitional relationship of mole. So 1 mole is equal to the mass of whatever substance you have. So we're always going to put the number 1 next to the unit mole. So there's step 8. Again, it doesn't matter whether mole's on the top or whether it's on the bottom, but you can see here that it will matter that you have mole in the right spot. So you can't just put mole wherever you want to put it. And here we knew that it went in the top because of this right here, because we had it at the back. Mole is the actual unit that we're looking to find. So because I'm looking to find mole, that means I can't have it canceled out. And that means it has to go in the numerator of this fraction bar. So that just leaves me with one number now. I just need to know what number goes here next to the unit gram. And it's always the same in this class. If you need a gram number, you go to the periodic table to get that gram number. So remember what I said. The definition of a mole is 1 mole is equal to the molar mass of that substance. And where's the molar mass coming from? It's coming from the periodic table. So we just need to go to the periodic table and find the mass of this substance, NH3. So this is where I like to stay organized. One of the things that I never did in high school, but now I'm all about organization. So I need to get the mass of this substance. So what we see here, if you think back to the first semester again, this particular substance is made of 2 elements. It's made of nitrogen and it's made of hydrogen. And we know that because both the N and the H are capitalized. So that tells us these are 2 separate elements. So this substance is made up of two different elements, but we also see a 3 here. So that means it's actually made up of 3 hydrogen atoms, but we don't see any number here next to the N. So remember, if we don't see a number, we can always put a 1. So that means that there's 1 nitrogen. So this substance ammonia is made up of 1 nitrogen and 3 hydrogens. So what I like to do to find the mass of this is to make a little chart here. So what I do is I always make this little table. So in the first column, I list out the elements that make out the substance. In the second column, I go to the periodic table and I find what the mass of that element is. In the third column, I multiply that mass by however many of those atoms I have in that compound, and then I get a total. And at the end, what I do is I take the total column and I add it up. And that there then is the molar mass of that substance. So let me put this next to the periodic table here. So I'm going to come here. So here's our periodic table. So it shrunk. Zoom in. So this substance here is made of nitrogen, it's made of hydrogen. So let's find these two substances. So on the periodic table, there's nitrogen. So we see here that the mass of nitrogen is 14.007 grams. So here I just ended up rounding up to 14.01. Depending on the periodic table you use, you may see 2 decimal points here, or like this one, you may see 3 decimal points. It's not a big deal. So that's what I put the mass there. So nitrogen on the periodic table has a mass of 14.07. So now I find hydrogen. So hydrogen is right there. So I look at that mass, it's 1.008. And again, here they rounded it, no big deal. Okay, so that's where those numbers come from. So now look at how many of each I have. So I go back to my chemical formula. And again, if you didn't write this down, you can see you wouldn't be able to do any of this. Again, why it's so important that you always write down units of measurement and chemical substances that you're measuring. So I look at my chemical substance and I see I have 1 nitrogen atom. So every nitrogen atom is 14.01 grams times the number I have, which is only 1. That means my mass of nitrogen in this substance is 14.01 grams. Now I do hydrogen. So I look at this substance and this is where this 3 comes into play. So this 3 means that I have 3 hydrogen atoms in this chemical substance. 1 hydrogen atom has a mass of 1.01 grams. So I'm going to take that and multiply it by 3. So that gives me 3.03 grams. So now I just find the total mass of this substance. So it's 17.04 grams when I add everything up. This now is what goes into that missing spot. So now look what you have. By following these steps, all of a sudden you have an equation that has developed. And this equation has everything filled in. That means you just have to go ahead and solve this. So what we have to do is we just cancel out the repeating units. Remember, if we see something twice, we'll cancel it. And now we just multiply across. So 2,000 times 1 mole of NH3 gives us 2,000 moles of NH3 on the top. And on the bottom, we multiply 1 times 17.04. So that's 17.04. And then we just divide. So we divide these out, and that gives us this. So this chemist is being asked to produce 2,000 grams of NH3. But again, his recipe is measured out in moles, so he needed to know how many moles he was looking to produce. So 2,000 grams of NH3 is the same thing or is equivalent to 117.37 moles of NH3. So there's the answer. Now he can look at his recipe and figure out how much of each ingredient he needs, because now the units of measurement match. So he now knows the number of moles, and his recipe again is measured in moles. All right, let's do some practice questions using this. So I'm gonna do a couple of practice questions on this. So again, like I said before, don't freak out about this. It's gonna take some time. So it's difficult material. So we just want to do a little bit of practice. It'll take a dozen or so practice questions before you really start to get comfortable with it. So the first thing that I want to do is just right here. So we're just going to practice calculating the molar mass of a substance. So calculate the molecular mass of each of the following molecules. So we're going to go down here, and that's just this part. We just need to practice going to the periodic table and figuring out what the mass of the substance is. So let me come over here. So in this, remember, because it's a mass, we're going to need the periodic table. So let me open the periodic table up next to this for the moment. Well, periodic table disappeared. Okay, this up. Okay, periodic table. So remember, what we want to do is create some columns. So this first column is simply where I list out the elements. So I'm going to put elements there. And then in the second column, we're going to write down what the mass of that element is. And then we're going to multiply that by the number that we have. So we come over to the next column. So number I have. And then over here, we now have a total mass. So that's going to be equal to a total. So the total mass of that element. So here's our first little practice one. So we look at this chemical substance here, and it's made up of 3 elements. And we know that because this K is capitalized, meaning it's its own element. The O is capitalized, so that's by itself. And then the H is capitalized, so that's by itself as well. So I'm just going to come down here and I'm going to list those out. So this element is made up of K, O, and H. Okay, so I'll list my elements out. Now I just need to get the mass of them. So I'm going to go find K on the periodic table, and there it is right there. So I look at the mass, it's 39.098 grams. So I'm going to put that down, 39.098 grams. Oh, bother. Move stuff over here. Okay. Okay. Now I find O. So I go to the periodic table. O is oxygen. So there it is. There's the mass of oxygen, 15.999 grams. 15.999 grams. And then lastly, H, hydrogen. So I find that one. So there it is, 1.008 grams. 008 grams. Okay. Now I need to multiply this by the number of each element that I have. So I look at my chemical equation here. So I don't see any numbers next to the K. So remember, that means you have only one. So I only have one K there. So down here, I go to the O, and again, I see no numbers. That means I have only one O. And for H, again, I see nothing. So that means I have one H there as well. This doesn't mean that you have 0 here. If you didn't have any of these, it wouldn't be listed. It wouldn't exist. So now we just equal this out. So 39.098 times 1 is just everything is the same. 0.098 grams. And then down here, 15.999 grams. And then 1.008 grams. So now all I have to do is total these out. So I'm going to come down here. So I'm just going to add these up. So I just go to my calculator. So we've got 39.098. And then we're going to add 15.999 plus 1.008. And that gives us 56.105 grams. So remember, you can't add or subtract numbers unless the units of measurement are the same. So that's another reason that it's so important to write units of measurement down. So notice here, all of these units are in grams. So there's our answer. So if I wanted 1 mole of this substance, if I wanted 1 mole of KOH, I would go to my scale, my balance, and I would put this compound on the balance until the balance read 56.105 grams. That would tell me that I had 1 mole of that substance. Or 6.022 times 10 to the 23 individual units of KOH. Let's take a look at this one. This one's a bit more complicated. Look at that. You got numbers in here and there's parentheses involved and more numbers. So this is why I wanted to pick this one, but we're going to do the same thing here. So we got the same columns. Let's fill this in. So let's fill those. So we need to always start by just listing out what elements we have here. And let me pull these out. And I'll get back to that. So look at this one. Here you have a capital S and a lowercase r. That means this is a single element. These go together. So one of my elements is SR. Next, I come over and I see a capital P, and next to it, I see a capital O. That means these are two separate elements. So one of my elements there is P, and the other is O, PO. Okay, so now I need to go down and I'm going to find the mass on these. So I go to the periodic table and I look for SR, and it's right there, element 38. So I look at the mass of this and it says 87.62. So 87.62. And remember, these are all gram numbers, grams. Next, I find P, and P is right there, element 15. So I see the mass here is 30.974. So 30.974 grams. Lastly, I have O, 15.999 grams. So there's our oxygen again. We're going to see that element all the time, grams. Now I have to come over here and I need to determine how many of each I have. So now you can see we're going to have more than one on some of these. So we got different numbers that are scattered around. So if we start by first looking at SR. So SR, right next to the SR, we see a number 3. So that means what we have here is 3 of those atoms in this chemical compound. These are now the hard ones. So there's a reason these parentheses are here. If you think back to math, anytime that something gets enclosed into a parentheses and you have a number outside the parentheses, that means that you need to take that number and distribute it into the parentheses. So remember, parentheses also mean multiplying. So we're multiplying the number through everything that's inside the parentheses. So here we have a 2 that's sitting outside these parentheses. So that means we're going to have to go ahead and distribute that 2 into the parentheses. So notice here we see no number next to the P, and next to the O we see a 4. So remember, if there's no number next to it, it means there's a 1 there. So we need to take this 2 times 1. So 2 times 1 is 2. So that means this chemical compound actually has 2 of these. So I'm going to multiply that by 2. Okay. Now what we have is we have to distribute it as well into the 4. So 2 times, again, parentheses mean times, so 2 times 4. So it means that we actually have 8 oxygen atoms in this chemical substance. So this one's a bit trickier. So now we're going to have to total all these out. So we're going to go to the calculator and we're going to do 87.62 grams times 3. So 87.62 times 3, and that's going to give us 262.86 grams. So that's the total mass of the strontium that we have in there. Next, we do 30.974 times 2. So 30.974 times 2. And we end up with 61, 0.948 grams. Okay, so there's that one. And lastly, 15.999 grams times 8. So let's see where that gives us. So 15.999 times 8 gives us 127.992 grams. So there we go. So now lastly, I'm going to take this column and I'm going to total it up. So I want to see what the mass is of the entire substance. So I'll just add all those together. So 127.992 plus 61.948 plus 262.86. And that gives me 452.8. So remember grams, so we have to look at the units to see if we can add them, and they're all the same here. So I'm going to talk about significant figures here. So some of you remembered when you're adding or subtracting, the number of significant figures is based on the least number after the decimal point. So if I look after the decimal here, I see 2 significant figures. Here I see 3, here I see 3. So that means this answer is going to need two figures after the decimal. So because I don't have one here, I'm just going to add a 0 to it. Again, not a big deal. So I don't want anyone freaking out about that. Move this over a bit. So this is the mass though. So if you wanted 1 mole of this chemical substance, you would need to go to the balance and keep adding it until you got 452.80 grams registered on the balance. So there's our practice with just finding the molar mass of a substance. What we're now going to do is we're going to do some actual conversions. So I got 2 conversion questions here that I'm going to go over. So let's get the steps out. So again, remember, what I want you guys to do, just like with all the other math questions, is I want you to actually have the math steps next to you so that you're able to check these. Let's open this up. So let's take a look at this question here. There we go. So this simply says, this is easy. So it says convert the following from grams to moles. So remember, the very first thing you need to realize is this is not a regular math question. And you know that because here in the question or the statement here, you see the word convert. So if we go up here, remember, if I see the word convert, it means that I'm doing this special process. And what does the word convert mean to me? It means fraction bars. So that means I need to get my mindset into these math steps. So let's take a look at the first thing we do. So if I recognize it as a conversion question, the very first thing that I need to do is rephrase the question using my parentheses. So I'm going to come down here and I'm going to rephrase this using my parenthesis values. So remember, in my first parentheses, I write the word convert. Then I close those off. And then the second thing, I put down my given. So how much am I given? So convert with my given. So what do I know? And I know this. So this is what I have been given. There we go. And then the last fraction bar is I need to turn this into my unknown value. What unit is it trying to get me to turn it into? So if I look at the question here, I want to go from grams to moles. So I have an unknown number of moles of H2O. I don't want to know grams of H2O. I want to know how many moles of H2O I have. So if I have 27.2 grams of H2O, how many moles is that equal to? So remember, we need to do this all the time because our recipes are always in moles. They're always measured in moles. So this gram number is not going to do anything for me. But I need to know the grams because I don't have any actual measuring equipment that measures in moles. So it's really a catch-22. It's annoying. But every single time you have to go back and forth from moles to grams. I can't count chemicals in grams and I can't measure in moles. So I have to know what the equivalent number for both is. So there's step 1. So I rephrased the question in this format. Now I'm going to take advantage of this and I'm going to go ahead and move on to step 2. So the first thing that I see when I look at my little note here is the word convert. So remember step 2, what that word convert tells me is, oh, I'm going to need some fraction bars. So this is going to help me. So this word convert means that I'm going to come in here and I'm going to put down some fraction bars. So let me just put those down. Again, we're not filling anything more than that in. We're just putting fraction bars down here. So I'm going to put 2 fraction bars down. So there's 1 fraction bar times a second fraction bar and then I put an equal sign down. So there we go. So that's what this got me. So here, this word convert got me the bones of the equation. Now I can start to put some flesh on it. So we're going to go down to step 3. So I look at my note and I see I've utilized this. This word convert has given me what it needs to give me. So the next part of my note is this number. So 27.22 or 27.2 H2O. Let me see if I can move this over here. Good. So remember, what do I do with this? The second part of my note always drops into the top of the fraction bar. So it always goes into this top spot. So that's step 4. We take the second part of the note and we drop it into the numerator of the first fraction bar. So I'm going to go ahead and plug that in there. So there we go. Now I can cross this out. This part of the note has gotten me some work done. So now I look at my note and I've got one thing left that I can do something with. So what do I always do with this? I go on to step number 4. Oops. So step 4 is to take this last part of the note and put it at the last part of my equation. So I just take it and I drop it into the back of the equation there. So there we go. So I'm out of note now. So my note is done. It's given me all that it can give me. But you can see here what it has given me is really important. It's given me the bones of the equation, and it's given me how the equation begins, and it tells me how it's going to end. So this note did a lot for me. So this is why it's so important to me that you all write this note every time, because it helps out immensely. It gives you a place to start, and it gives you a place to end. All right, so next we go on to step 5. So we now, let's see. So we now place a 1 in the denominator of the first fraction bar. Again, this is always the same. It doesn't matter what else is going on in here. We always come right underneath here to the denominator of the first fraction bar and we put a 1. And again, that's just to keep us from putting something else in there. We don't want to put anything in there. And that 1 is a placeholder. It blocks me from putting anything else in there. Now we can go on to step 6. So in step 6, this leaves us with 2 blanks. So I need to fill these in. So the next thing that we do, and the reason that I put this down here is because whatever this is always flips and goes into this spot right next to it. So I'm going to go ahead and drop that in there. So moles of H2O is what's going to go into that spot right there. So there's step 6. Again, it's always the same. It doesn't make any difference what this word right here is. Always flips to this spot here. Now, all of a sudden, I only have one thing left. So this note is actually still helping me. Because this note reminded me to put this here, I'm then able to use this and flip it over here. So step 7, I need to fill this spot in. I need to know some unit of measurement here. So notice I didn't put any number here yet. We never put numbers into this until we have units of measurement in both the top and the bottom. So we're never going to put any number in here because I don't know what I'm comparing it to. So step 7, where do I get this from? I always get it from the same spot. Whatever I'm trying to cancel out is what goes there. So I'm trying to cancel out whatever I start with. So in this case, grams of H2O. So here, I'm going to go ahead and flip that down. So that's what's going to go down there. There we go. So again, this note, because the note told me to put this here, it actually also continued to give. It was the gift that keeps on giving. So it moved my units of measurement down and allowed me to put this here. So there we go. I filled that in. Now all I have to do is put the numbers here. So we go on to step number 8. So remember, the unit mole always gets a number 1 placed next to it. So I look into my equation and I find where my mole is. So here's my mole in this equation. That means I'm going to put the number 1 next to it. So there's number 1. Look at that. Now all of a sudden I have almost the entire equation done. I just need a single number here. And where does that number come from? That's step 9. So we look at this unit of measurement and it says grams. So in this class, I think, what am I supposed to do with grams? Whenever I see grams, what does that mean? And what it means is periodic table. Every time we see grams, we have to go to the periodic table. So I need to get the mass of my chemical substance. And again, now you can see repeating why it's so important that you've written down what your chemical substance is. If you just had grams here, or even worse, if you just had the number 27.2 here, you'd have no idea where to get the number from this, because you wouldn't know that you needed to get the mass of H2O. So remember, whenever we go to the periodic table, whenever we get our mass, we need to do our table. We need to put our chart together. So not chart, but our table together. So that's what I got down here. So remember, the table is always the same. So it's the same same 4 rows there. So I'm going to put this together. Okay. So this is why we did this practice up here. So we need to get the mass of this chemical compound. So this chemical compound is H2O. So we look at it and it's made up of an H and we see an O. Both are capital. So that means these are 2 separate elements. So my first element here is H. My second element is O. Okay, next I need to get the mass. So where do I get mass numbers? Always the same again. I always get mass numbers off the periodic table. So let me open up the periodic table, which of course has disappeared. So let's get this periodic table open. Always the hard way. Okay, so my first element I need to find is H. So I find H, there it is again, we've used it a few times. And the mass is 1.008 grams. So remember, these are all gram numbers, and we always put the units down. And then O, again, another one we've used a few times, 15.999 grams. 9 grams. Now I have to multiply by the number that I have. So how many H's do I have? So I look at my chemical equation, and next to the H, I see the number 2. There's a better view of it. I see the number 2. So that means I have 2 hydrogens in this substance. And then my O, I need to know how many I have. So I go here, and here I see no number. So remember, that means I have 1 oxygen only. Now I just multiply these together, and I put these down. So 1.008 is going to give me a mass, or times 2, it's going to give me a mass of 2.016 grams. So again, we always put our units of measurement down, and 15.999 times 1, we just end up with the same thing, 0.999 grams. So then we come down here and we're going to do the total. So we just add up this column so that we can see what the total mass of the substance is. So 2.016 plus 15.999. And so the total mass of 1 mole of this chemical substance is 18.015 grams. 18.015 grams. So remember, what the heck did I find this for? What's the point of that? Let's see. So the point of that is, that's the number we were looking for. So if we go back here to step number 9, the point of that is we just found a gram amount. Again, why units are so important. This unit here matches with this unit, so that's where this number goes. 18.015, and then G. So see, this is a G number. That was a G unit there. So that's it. By following these steps, I've set this whole equation up without trying to guess or think ahead as to what it's going to look like at the end. So now all I have to do is multiply across and then divide. So I'm going to come here and multiply across. So 27.2, and notice we canceled these out. This number doesn't cancel out. So we cancel these 2 units out because we see them twice, grams and grams. So 27.2 times 1 mole of H2O is 27.2 moles of H2O. and that's going to be on the top. And then on the bottom, let me take the time to put an equation in here. I'll put the actual fraction bar down. So 27.2 moles H2O. So that's on top. And on the bottom, I do 1 times 18.015. So 18.015. And I've canceled that unit out, so that's it. Get rid of this so it's not confusing. And then that's going to be equal to moles of H2O. Mole of H2O. So now we just divide. So 27.2 divided by 18.05. So we punch that into the calculator, and 27.2 divided by 18.015. And I get 1.5098529. And then my unit of measurement is moles of H2O. So again, we want to make sure that we round this correctly. So I look at my original measurement here, I only had 1, and it has 2 digits in it. So that means my answer needs to have 3 digits, sorry. So this is the number that gets rounded. So digit 1, 2, 3. Again, this is not a big deal here, so we don't want to freak out about it. So I'm going to round it right there. So 1.5, and I look behind the 0 and I see a 9, so this becomes 1 moles of H2O. So there's your answer. There's unit conversions. All unit conversions are exactly like this. It's the same thought process. And it's, again, why these steps are so important. So remember, these steps were utilized by me personally for years and years and years because they were universal, because I was able to take the same thought process into a lot of different situations to help me out. So that's why this is, again, so important to me here. All right. So let's take a look at this next question. Let me move this down here, get some cutoff going. We'll actually change this. So let's say here, so now we got a second question we want to look at. So convert moles to grams for the following. So moles to grams for the following. So again, I see the word convert here. What that tells me is I've got a unit conversion question going on here. So let me move this. So as soon as I recognize that I have a conversion question, because I see the word convert, I need to think, all right, I need to get my steps down. And step number 1 is to rewrite the equation. So we look at step 1 is to rephrase it using the parentheses. So convert, and then always in my first one. My second one is always whatever I'm given. So I'm taking my given amount. And that's going to be, in this case, this. So remember, we don't just write down the measurement. We write down what chemical substance we're measuring as well. Yeah, what's up with this stuff? Huh. There we go. Okay. Yep, still. Okay. So there's our second fraction bar. So we convert this. So then our third fraction bar is always what it wants. So it's giving us moles of a substance, but it doesn't want that. It wants you to convert it into something else. So we come up here, it doesn't want moles, it wants grams. So our third fraction bar is we need some unknown amount of grams of NH3. So then I close that off. Okay, there's step 1, always the same. As soon as I recognize I have a conversion question here, I rephrase the question. I rewrite it to make sure that I make this more, so that I put it in a format that I recognize every time. So The question itself may change, the units may change, but if I rephrase it this way, it puts it in a form that my brain recognizes and knows what to do with. So that's what we got going on here. So now I can actually utilize this note. So we always start at the beginning of the note. So remove this. I hate having to use this computer instead of just writing stuff down. So the word convert always tells me to do the same thing. So I see the word convert right there. It means fraction bars. So I'm going to come in and I'm going to put my fraction bars in here. So I see the word convert here. So insert fraction bars. So I'm going to insert these fraction bars times and get another fraction bar in there. And then equals. Okay. So that's always step number 2. Now I'm done with the word convert. It's helped me out a lot. It told me exactly what to do. So let's cross that out. So we come into the next part of the note. So what do I always do with the next part of the note? That's step 3. I drop it down into the numerator of the first fraction bar. So I'm going to go ahead and drop it in there. So 1.5 moles NH3. Okay, there's step number 3. Now I can cancel that out. That helped me out. So I still have some note left. What do I always do with the ending part of the note? Again, it doesn't matter what this ending part of the note says. Could say grams, could say liters, could say time, could say seconds. It doesn't really make any difference. There's a lot of measurements you can turn from one into another. So this is where we're on step 4. So we take that ending part of the note and we drop it into the ending part of the equation. So boom, put it in there. Now I'm done with this. So my note has been exhausted, so I don't have anything else to use for the note there. But fortunately, again, what this note did is it gave me some bones and it gave me a beginning and an ending point. So I have a beginning to my equation and an ending to my equation. So it's given me some boundaries to work within. So next I just go on to step 5. So I just have to fill in these 3 boxes. And remember, these 3 boxes always come from the same spot. So the first one we always want to fill in is number 5. We always want to put a 1 underneath in the denominator of the first fraction bar. So we'll put a 1 right there. So there's step 5 every time. So step number 6. Now I have only 2 boxes left that I need to fill in. So remember, the reason that I did this, the reason that I put this into the back is because it allows me to fill in another part of the equation. So if I know what I'm ending in back here, I know that that particular unit of measurement must have come from right here. So if I want to end in grams of NH3, that must mean that this particular part of the equation says grams of NH3. So that's step 6. We take what we end in and we flip it in there. So now I have only 1 spot left. So again, same spot every time. The denominator is always used to cancel something out. So the denominator of a fraction is always used to simplify or to cancel an overall fraction or equation. So what do I need to cancel out here? And it's always the same. Whatever I start with, so this is step 7, whatever I start with gets flipped down. So here, what I started with was moles of NH3. So that means I need to cancel this out. In order to do that, I need to flip it. And all right, Cambrian math. That's a new one. So moles of NH3. Hey, there it is. So that gets flipped down there. So again, notice I didn't put any numbers in here yet. You can't put numbers in here without both measurements in because you don't know what you're comparing. You don't know what your relationship is. So now we can see we're looking for a relationship between grams and moles. So now we go on to step 8. Now I can put my numbers in. So remember, the beauty of the mole is we always put a 1 next to it. So if I see mole, I put a 1 next to it. Look how this one is different from the last one. So in our last one, we saw that mole was sitting up at the top there. Now you can see that mole is at the bottom. This equation has now switched on you, but because you followed these steps, you didn't even notice it just happened. It did it on its own. You didn't have to think about this. So this is one of the most common problems I see for people who are students who are just beginning to do this, is they always put the mole in the same spot. So they'll always put the mole at the top. But that's not true if we're trying to convert into something other than moles. Whatever you put at the top here is always the unit of measurement you're trying to convert into. So here we're not trying to convert into moles. We're converting into grams. So here we see the mole now ended up at the bottom. So this is one of the reasons the kids, like I said, struggle, is they try to memorize what the question is asking you to do. So they read the question and then they try to memorize, oh, is the mole at the top or on the bottom? If you follow these steps, you don't have to memorize anything. Everything just builds itself on its own. And it's all, at this point, the numbers are always still the same. The number 1 always goes next to the unit mole. So I'm going to put a number 1 down there. So I see the mole down there. That means the 1 goes next to it. So now I only need to find something to put into this spot right here. I need a gram number. So again, I think gram, where do I get that from? And again, the answer is always the same. In this class, when you see grams, we head to the periodic table. That means we're now on step 9. We got to put our chart together. So we're going to do our chart here. So that means I need the periodic table. I see a gram unit. It means that I'm going to need my periodic table. Nope, that's not what I want. There's got to be an easier way. All right, so let me come back over here. So I put my table here. So again, let me copy this. Table's always the same. So again, it's important to me that everything that what I'm asking you all to do is the same every time you do it. If everything that I asked you all to do had only one use or was only good one time, what I'd be asking you to do would be useless. That's the last thing you want to do. You don't want to spend your time trying to come up with things that only have one use to them. You want to find something that can be used in different situations over and over and over again. So you want to create something that can be applied to a lot of different situations. And that's what I'm doing here. So we got elements, the mass of the element, the number that you have, and then the total mass. So let's put total mass there. So I'm going to look at my chemical substance, and I see my chemical substance here is NH3. So this chemical substance is made of a nitrogen atom and a hydrogen atom. And I know that these are 2 separate elements because they're both capital letters. So that means I can go in here. So I have nitrogen as one element and hydrogen is my other element there. So, okay. So now I just need the mass. So I go to the periodic table again, grams. Grams always tells me periodic table. So there's my nitrogen. So I see the mass is 14.007. So I just log that down, 0.007 grams. And again, always put your unit of measurement on. These numbers on the periodic table are gram numbers. And then hydrogen, I find, again, these same elements show up over and over. So here, hydrogen, 1.008 grams. So 1.008 grams. Okay. Now I just multiply these by the number that I have. Okay, so I look at my chemical substance and I see nitrogen. I don't see any number there. That means this is a 1. Okay, and then I look at my hydrogen and I see a 3 there. So that means that this 3 goes with the hydrogen. So it means that I have 3 hydrogens there. So now I just total it out. So 14.007 grams times 1 is going to be the same value, 0.007 grams. And then down here, 1.008 times 3, 1.024 grams. So that's the mass of each element within this. Now I just have to get the total mass of the entire chemical substance. So I add these together. So we do 14.007 plus 1.024. And then we just add that down. So 15.031, and then grams. Again, units are so important because this unit is what allows you to say, oh yeah, the reason I was doing this is because I actually needed a gram number here. So these units match. So now I can go ahead and transfer this number up here. So 15.031, and then that's grams. So there we go. Now I have my equation completely built. And again, you didn't really have to think about anything. You weren't figuring anything out here. You were simply following steps, and the equation built itself up. So as you did each of these steps, the equation slowly built itself up. So that's where we were. So we just finished step 9. So step 10, we cancel out the units we see repeating. So I see moles twice, so I cancel it. And now I just do the math. I multiply across and divide. So I'm going to come here and I'm doing 1.5 times 15.031 grams of NH3. So I just punch that into the calculator. And I get, let me again put a fraction bar down there. And so I'm just going to move this over here. That got moved over here. So what we get is 22.5465. And then the unit of measurement that I'm left with is grams of NH3. So grams of NH3. And then on the bottom, it's 1 times 1. So on the bottom here, I have 1. And then this is going to be equal to, oops. Yeah. Nope. So equal to grams of NH3. So now I just divide out, and obviously anything divided by 1 is itself. So this ends up being my answer, except I just need the right number of digits. So here I look at my original measurement and I see I only have 2 digits. That means I need to round it to this guy. So there's my second digit. So I look behind it and I see a 5. So that means this 2 gets rounded up. So it becomes 23. That is some really small writing. It becomes 23 grams of NH3. And there's your final answer. So if I'm the chemist and my recipe calls for 1.5 moles of NH3, I'm going to have to go to the scale and measure out 23 grams of NH3. That will then be 1.5 moles. So again, remember, we don't have an equipment that actually measures in moles. You can't get a readout that says moles of NH3. The only thing we can do is convert it using this process into a mass measurement, which we can then go to the balance for and mass out. So this is unit conversion. So again, this is really important to me that you follow these steps, because throughout your science career, so during this year and then especially in physics next year, you're going to be asked all the time to convert one unit to another. It will give you a measurement in one unit like this, and then it'll ask you to put your answer in a different unit of measurement. So you'll constantly be having to use this process. But the beauty of these steps is it works for any type of conversion. So it doesn't matter what the units are that it's asking you to do. You don't have to try and memorize 1,000 different versions of this same thing. You simply use these steps and allow the steps to do the problem for you. So that is, again, that's the beauty of it and why it's so important to me that you do this. So that was a lot. I realized that, but I did want to have this up here for you so you could watch it, as many times as you need to and work through the questions with me, basically. So as you go along, listen to me do the steps and everything, and then just fill in your own practice questions step by step. So I definitely appreciate you guys taking the time to listen. Thank you.